cables, electronic communication, telephone wires, cables, electronic devices, medical system, particularly in Ayurvedic system, formation of alloys for various purpose. For example, steel alloys, agriculture as fertilizers, seed dressing, fungicides, for example, gineb containing zinc, manib containing manganese, etc. Jewelry, for example, gold, silver, platinum, diamond, based on their properties. Minerals are basically of two types. Number one is the non-metallic, number two is the metallic minerals. Non-metallic minerals are the graphite, diamond, quartz, feldspar. These are the non-metallic minerals. Which one is non-metallic minerals? Is graphite, diamond, quartz, feldspar. These are the non-metallic minerals. Metallic minerals are the bauxite, laterite, hematite. These are the metallic minerals. Metallic minerals means metal content is more in this mineral. Bauxite have the metallic mineral is a laterite also metallic. Hematite also. Hematite means iron ore. These are the have the minerals. The use of the metals by human beings has been so extensive since the very beginning of human civilization that two of the major epochs of human history are named after them as Bronze Age and Iron Age. The reserves of the metals and the technical known how to extract them have been the key elements in determining the economy and the political power of the nation. Out of the various metals, those used in maximum quantity are iron and steel, 170 million metric tons annually, followed by the manganese, copper, chromium, aluminum, and nickel. These are the following minerals. Distribution of distribution and use of the some of the major metallic and non-metallic minerals. Within that, we have the given chart. It is a major resource important to use some of the major metals in the worldwide. Number one is aluminum. Aluminum is a major world resource is Australia and Jamaica, Guyana. These three countries have the major deposits in aluminum in worldwide. Major uses is the packing food items, transportation, utensils, electronic purpose. These aluminums are used. Chromium is available in the major GIS South Africa. These two places it is available. For the major use is the making high strength steel alloys in textile tanning industries. Copper it is available in the USA, Canada, CIS, Chile, Zambia. These five countries it is available. The copper deposit morely available. This copper is the using electric and electronic goods, building, construction, vessels purpose they are using. Iron is available in the CIS, South America, Canada, USA, majorly available in this place only. Heavy machinery, steel production, transportation means. Lead, North America, USA, CIS. These places is available. Leaded gasoline, car batteries, paints, and so what are the minerals? Minerals are the naturally occurring inorganic, crystalline, solid, having a definite chemical composition, Character physical properties. Name it. There are thousands of minerals occur in different part of the world. However, most of the rocks there are thousands of minerals occurring in different part of the world. However, most of the rocks we see every day just composed of a few common minerals like quartz, feldspar, biotite, dolomite, calcite, halides, etc. These minerals in turn are composed of some elements like silicon, oxygen, iron, magnesium, calcium, aluminum, etc. These minerals have it the silicon, oxygen, iron, magnesium, calcium, aluminum, etc. Uses and exploitations of the minerals. The minerals find use in every sphere of our life. The minerals are used in a large number of ways in domestic, agricultural, industrial, and commercial sectors, and thus form a very important part of any nation's economy. The main use of the minerals are follows. Number one is the development of industrial plants and machinery. Number two is the generation of energy. Example: coal, lignite, uranium. Number three is the construction means housing settlements. Four is the defense equipments, weapons, ornaments, transportation, communications, telephonic wire, cables, electronic devices, medical system, particularly in Ayurvedic system, formation of alloys for various purpose. Example: steel alloys, agricultural effect as fertilizers, seed dressings, and fungicides. For example, zinib containing zinc, manib containing manganese, etc. Jewelries is, for example, gold, silver, platinum, diamond. Based on their properties, minerals are the basically two types. Number one is the non-metallic minerals. Number two is the metallic minerals. Non-metallic minerals are the example of the mineral graphite, diamond, quartz, feldspar. These are the non-metallic minerals. Means they don't have the any metallic property. That's why these are the non-metallic minerals. Metallic minerals are the have the definitely have the metal property. Best example is the bauxite, laterite, hematite. These are the have the iron ore content in the more in metallic structure, metallic mineral. The uses of the metals are human beings have has been too extensive since the very beginning of human civilization that two of the major epochs of the human history are named after them as a Bronze Age and Iron Age. The reserves of the metals and the technical known how to extract them have been the key elements in in determining the economy and political power of the nation. Out of the various metals, those used in maximum quantity are iron and steel, followed by the manganese, copper, chromium, aluminum, and nickel. These are the commonly used minerals. Distribution of the use of the minerals. It is in the major use of the important of the major metals. Major metals are the aluminum, chromium, copper, iron, lead, manganese, platinum, gold, silver, nickel. These are the major metals. Within that, where it is available, aluminum is available in the Australia, Jamaica, and Guiana. These countries, the aluminum is available. For the major using is the aluminum packing food items, transportation, utensils, electronics. Chromium is available in South Africa and CIS for the uses is for making high strength steel alloys in textile tanning industries. Fourth one is the copper. Copper is electronic, electrical goods, building, construction, vessels. Iron Iron is available in heavy machinery, steel production, transportation means. It is available in the South America, Canada. Manganese for making high strength heat resistant steel alloys. Platinum, South Africa, CIS. Use in automobiles, catalytic conversions, electronics, medical uses. Gold, South Africa, CIS, Canada. Ornaments, medical, electronic uses, use in aerospace. Silver, Canada, South Africa, Mexico is a majorly a producer of these countries. Photography, electronics, jewelry. Major use of the some non-metallic minerals. Non-metallic means silicate minerals. Silicate minerals are sand, gravels for construction, bricks, paving, etc. Limestone used for the concrete, building stones used in agriculture for neutralizing acid soils used in cement industry. Gypsum used in plaster wall board in agriculture. Sulfur pyrites used in medicine, car battery industries. These are the some non-metallic minerals. It is evident from the tables that the CIS countries, the Commonwealth of Independent States, CIS countries means 12 Republic of former USSR, United States of America, Canada, South Africa, and Australia are having the major world reserves of the most of the metallic minerals due to the huge mineral energy resources. The USA became the richest and the most powerful nation in the world in even less than 200 years. Japan too needs a mineral mentioned here as there are virtually no metal resource, coal, oil, timber resources in Japan, and it's totally dependent on other countries for its resources, but it has developed energy efficient technologies to upgrade these resources to high quality finished products to sustain its economy. Minerals are sometimes classified as critical and strategic. Critical minerals are the essential for the economy of a nation. Example: iron, aluminum, copper, gold, etc. Strategic minerals are the those required for the defense of a country. Example: manganese, cobalt, platinum, chromium. These are the strategical minerals. Some major minerals of India: energy generating minerals. These are coal and lignite. It is available in West Bengal, Jharkhand, Orissa, Madhya Pradesh, Telangana, Andhra Pradesh, as well as uranium, pitchblende or uranium ore. Uranium is available in the Jharkhand, Andhra Pradesh, and Telangana. It is Andhra Pradesh in Nellore, Telangana in Nalgonda, along with Pachapeta area in Mahabubnagar district. Meghalaya and Rajasthan. In Rajasthan, Also, Ajmeri area is available in uranium. Other commercial used minerals are the aluminum means bauxite ore, Jharkhand, aluminum is available in Jharkhand, West Bengal, Maharashtra, Madhya Pradesh, Tamil Nadu. Iron means hematite, magnetite ore, available in Jharkhand, Orissa, Madhya Pradesh, Andhra Pradesh, Telangana, and Tamil Nadu, Karnataka, Maharashtra, Goa. Copper pyrites is a Rajasthan means K3. Bihar, Jharkhand, Karnataka, Madhya Pradesh, West Bengal, Andhra Pradesh, and Uttarakhand. These states is available in these minerals. So environmental impact in mineral extraction and uses. Environmental extraction. The issues related to the limits of the mineral resources in our earth crust or in the ocean is not so significant. More important environmental concern arises from the impact of the extraction and the processing of these minerals during the mining, smelting, etc. The Indian scenario, India is the producer of the 84 minerals. The annual value of this is about 50,000 crores. At least six major mines need a mention here, which are known for the causing severe problem. Number one is the Jaduguda uranium mines in Jharkhand, Jaria coal mines in Jharkhand, Sukinda chromite mines in Odisha, Kudramukh iron ore mines in Karnataka, East Coast bauxite mines in Odisha, Northeastern coal fields in Assam. These six mines are the facing several problems. Number one, Jaduguda uranium mines is located in Jharkhand, exposing local people to radioactive hazards. Jaria coal mines is located in Jharkhand state. Underground fires associated with two land subsidence leading to forced displacement of the people. Sikinda chromite mines, which is in Orissa, seeping of hexavalent chromium into river, posing serious health hazard. Chromium 6 being highly toxic and carcinogenic minerals. Thus, Kudramukh iron ore mines is located in the Karnataka state, causing river pollution and a threat to the biodiversity. East Coast bauxite mines in located in Orissa, land encroachment and the issue of the rehabilitation unsettled. Northeastern coal fields is the Assam, sulfur contamination of the groundwater. Impacts of mining: the mining is done to the extraction minerals or fossil fuels from these from the from deep deposits in soil by using subsurface mining, or from the shallow deposits by surface mining. The former method is more destructive, dangerous, and expensive, including risk of the compositional hazards and accidents. Surface mining or minings can make use of the many of any of the following these types. Number one is the open pit mining. Two is a dredging mining. Third one is the strip mining. These is the minings are there. First one is the open pit mining, in which machines dig holes and remove the ores. Example: copper, iron, gravel, limestone, sandstone, marble, granites. These are the open pit method. Dredging, in which chained buckets and draglines are used, which scour up the minerals from underwater. Strip mining, in which the Ore is stripped off by using bulldozers, power shovels, and stripping wheels. Example phosphate rocks. Mining activity in hill disturb the ecology of the region. Garhwal Hills, Uttarakhand. The environmental damage caused by the mining activity are the follows: devegetation and facing of landscapes, the, the topsoils as well as the vegetations are the removed from the mining area to get access to the deposit, while large scale deforestation or devegetation leads to several ecological losses. Ecological losses, as already discussed in the previous section. The landscapes also get badly affected. The huge quantities of debris and tailing, along with big scars and disruptions, spoil the aesthetic values. Subsidence of the land. Subsidence of the land is that this is mainly associated with the underground mining. Subsidence of the mining areas often result in tilting of buildings, rocks, cracks in house, buckling of roads, bending of the rail tracks, leaking of the gas from cracked pipelines, leading to serious distributors. Third one is the groundwater contamination. Fourth one is the surface water pollution. Fifth one is the air pollution. The groundwater contamination, the mining disturbs the mineral hydrological process and due to several water pollutions. The acid the surface water pollution, the acid mine drainage of the contaminates the nearby the streams and lakes. The acidic water is detrimental to many forms of aquatic life. Sometimes radioactive substances like uranium also contaminate the water bodies through mine waste and kill aquatic minerals. Heavy bodies, heavy metal pollution of water bodies nearby the mining area is a common features creating health hazards. Air pollution in order to separate and purify the metal from other impurities in the ore. Smelting is done with which emits enormous quantities of air pollution, damaging the vegetation nearby the has serious environmental health impact. The suspended particulate matter shoot arsenic particles, cadmium, lead, etc. Shoot occupational health hazard. Most of the miners suffer from this various respiratory and skin diseases due to constant exposures to the suspended particulate matter and as remedial measures in order to minimize the adverse impacts of the mining. It is desirable to adapt to eco-friendly mining technology. The low-grade ores can be mined. The microbial leaching techniques. The microbial has successfully and economically used for the extraction of gold embedded in iron sulfide ores. The ores are inoculated with the desired, desired strains of the bacteria which remove the impurities and leave the pure mineral. This biological point of view, the resource restoration of mined area by revegetating them with the appropriate plant species. Restoration mining area revegetation then with appropriate plant species help in the stabilization of the mined lands and a gradual restoration of the flora. Prevention of the toxic drainage discharge and conforming to the standards of air emissions are essential for minimizing environmental impacts of the mining. The case studies, the improper waste disposal in Malani finds copper mines acidic threats. Acres and acres of land in the waste dump of the Malani copper mining project in Balaghat's Bisra Black, Madhya Pradesh are a vast spread of the white sand in the toxic waste at the present 2 million tons of the copper are being extracted from an open cast mine, and the mining is going to be intensified. And the project is very important for the development of our country. But the nearby village have to pay big environmental prices. The waste has the resource has highly acidic bluish green water that comes down only when it drink this acidic water. Suffer from several diseases. Some villages in the National Environmental Engineering Research Institute means the Navy has environment registered government of India company Navy is carrying out detailed environmental assessment of the project on instructed from the engineering. Mining and quarrying in Udaipur, about 200 open cast mining and quarrying centers in Udaipur, about half of which are illegal or involved in stone mining, including soap stones, building stones, rocks, phosphates, and dolomites. The mines spread over 15,000 hectares in Udaipur have caused many adverse impacts on environment. About 150 tons of the many adverse impacts on environment. About 150 tons of the explosives are used per month in blasting. The overburden wash off, discharge of mines water, etc. pollute the water. The mining in Silistra hydrologics in Aravalis. The Aravali range is spread over almost mining operations around the Silistra hydrologics. From and the land. The precious wildlife is the series must preserve as and the Supreme Court on reviewers wherein both central and state government Rajasthan created minings in Nalanda and Lachindaka public participation of the present years unions in Jatipura mines could reply them supplemental indicate only spiritual for there was before the European proportion implemented policy proposed to mine revenue from the deposits of the Rambagh and ways of Nalanda districts. Processing about 18 kilometers Mayapur. The plan was to extract up to 11 million tons in 20 years. The UCIM has trying its best to allow unlit the villages thousand. The proposed mines could be just controls from the human habitation and the hardly from the Rajasthan. Then the habitations and the mountain construction continuous mining would generate about 7.5 research. Would generate about 7.5 million metric tons of the radioactive waste, which 99% would be left behind the villages very sensitive. The villages are obviously affected by the radioactive waste. So you see plans that they won't be definitely. Simple grammar. వీళ్ళకి వచ్చారు. The proposed mines will cover about 440 acres of the Yellappuram Reserve Forest and Rajiv Gandhi Tiger Sanctuary. The public hearing will be held with strong protest from the NGOs and the fate of the proposed mines will be decided. Next one topic is the food resources. We have the thousands of the edible plants and animals over the world, out of which only about the 3 dozen types constitute the major food of the humans. The main food resources include wheat, rice, maize, potato, barley, oats, potato, sweet potato, sugarcane, pulse, sorghum, millet, about 20 are so common fruits and vegetables, milk, meat, fish, and the seafood. Amongst these rice, wheat, and maize are the major grains. About 150 million metric tons of which are grown each year, which is about half all the agricultural crops. About 4 billion people in the developing countries have wheat and rice as their staple food. The meat and milk are mainly consumed by the more developed nations of North America, Europe, Japan, who consume about 80% of the total. Fish and seafood contribute about 70 million metric tons of high quality protein to the world diet. But there are indications that we have already suppressed sustainable harvest of fish from most of the world oceans. The Food and Agriculture Organization (FAO), the Food and Agriculture Organization of United Nations estimated that on an average the minimum caloric intake on a global scale is 2,500 calories per day. People receiving less than 90% of these minimum dietary calories are called undernourished, and if it is less than 80%, they are said to be seriously undernourished. Beside the minimum caloric intake, we also need proteins, minerals, etc. Deficiency or lack of nutrition often leads to malnutrition, resulting in several diseases like important impact of the malnutrition in that proteins and calories, iron, calories, health effects, stunted growth, malnutrition. The major food resources of the world are three followed. And number one is the major crops on which humanity depends on as staple food are the wheat, rice, maize, nearly 1,600 million metric tons of these three grains are the growing annually. About 60% of the calories consumed by the human being over the world, mainly developing countries, come from wheat and rice. The two crops belongs to the grass family, developing countries, wheat and rice, like in India also same. In mountain regions, potatoes and barley, oats, are staple foods. The northern Europe and the North Asia, these crops are growing well in the cool and moist climate. In warm, wet areas of the Africa, Amazonia, and the South Pacific, sweet potatoes, cassava, and other tuberous underground crops are the staple food. In dry regions of Africa and other desert areas like that in the Rajasthan, the drought resistant sorghum and millet are important staple food resources. A great variety of fruits like banana, mango, apple, grapes, pineapple, avocado, lychees, pears, plums, citrus, fruits, etc. are the a rich source of vitamins, minerals, carbohydrates, and fibers. Around 20 types of vegetables, including leafy and fleshy, are common food resources. Rice resources rich in minerals and vitamins. About 15 species of pulses are rich sources of proteins. About six mammals, two types of the domestic fowls, a few fish species, and a half a dozen marine animals constitute a majority of the food consumed by the humans. Animal food resources are rich in proteins and fats. Seafood and sea fish are rich in phosphorus. About 80% of all the meat and milk produced in the world is consumed by around 20% of people living in North America, Europe, and Japan. Just as the Green Revolution was promoted to boost up our food grain production, Blue Revolution was initiated to produce more fish, shellfish, shrimps, oysters, etc. in aquaculture. Although India is the third largest producer of the staple crops, an estimated 300 million Indians are still undernourished. We have only of as much land as USA, but have nearly three times population to feed. World food problems. During the last 50 years, world grain production has increased almost three times. During the last 50 years, world grain production has increased almost three times, thereby increasing per capita production by about 50%. But at the same time, population growth increased at such a rate in LDC. LDC means less developed countries that it outstripped food production. Every year, 40 million people, 50% of which are young children between 1 to 5 years, die of the undernourishment and malnutrition. This means that every year our food problem is killing as many people as were killed by the atomic bomb dropped on a Hiroshima during World War II. These startling statistical figures more, more than emphasize the need to increase our food production, equitable distribute it, and also to control population growth. Indian scenario, although India is the third largest producer of the staple crops and estimated 300 million Indians are still undernourished. India has only of as much land as USA, but it has a nearly three times production of the food. Our food problems are the directly related to the population. Now, the World Food Summit 1996 set the target to reduce the number of undernourished to just half by the 2015, which still means 410 million undernourished people on the earth. In fact, of the overgrazing and agriculture. Overgrazing and agriculture. This production of food and fodder have an impact on the environment. Overgrazing livestock wealth play a crucial role in the rural life. of our country. India leads in livestock population in the world. The huge population of livestock needs to be feed, and the grazing lands or pasture areas are not adequate. Very often we find that the livestock grazing on a particular species of the grassland or pasture surplus surpass the carrying capacity of any system is the maximum population that can be supported by its own unstable basis sustainable basis. However, most often the grazing pressure is so high that its carrying capacity is crossed and the sustainability of the grazing lands fails. Let us see what are the impacts of the overgrazing land degradation. Number one is the land degradation, number two is the soil erosion, number three is the loss of useful species. Number one is the land degradation. Overgrazing leads to multiple actions resulting in loss of soil structure, hydraulic conductivity, and the soil fertility, as explained above. Overgrazing removes the vegetal cover over the soil, and the exposed soil gets compacted, due to which the operative soil depth declines. So the roots cannot grow much deep into the soil, and adequate soil moisture is not available. Organic recycling also declines in the ecosystem because not enough detritus or litter remains on the soil to be decomposed. The humus content of the soil decreases. The overgrazing leads to organically poor, dry, compacted soil due to trampling by cattle. The soil loss infiltration capacity, which reduce percolation of water into the soil. As a result of this, more water gets lost from ecosystem than with surface runoff. Soil erosion due to the overgrazing by cattle, the cover of vegetation almost gets removed from the land. The soil becomes exposed and gets eroded by the action of the strong wind, rainfall, etc. The grass roots are very good binders of the soil. Then the grasses are removed, the soil becomes lost and susceptible to the action of wind and water. Third is the loss of useful species. Overgrazing adversely affects the composition of the plant population and their regeneration capacity. The original grassland consists of the good quality grasses and herbs with high nutritive values. When the livestock grazing upon them heavily, even the root stocks which carry the resource food for regeneration get destroyed. Now some other species appear in their place. These secondary loss of useful species. Overgrazing adversely affect the composition of the plant population and their generation capacity. The original grassland consists of good quality grasses and the herbs with high nutritive value. When the livestock graze upon them heavily, even the root stock which carry the reserves food for regeneration get destroyed. Now some other species appear in their place. These secondary species are hardier than- and are less nutritive in nature. Some livestock keep on overgrazing on these species also. Ultimately, the nutritious, juicy fodder giving species like centuries as a result of the overgrazing. Very vast areas in Arunachal Pradesh and Meghalaya are getting invaded by thorny bushes, weeds, etc. of low fodder value. Thus, overgrazing makes the grazing land lose its regenerating capacity. Once good quality pasture land gets converted into an ecosystem with poor quality thorn vegetation. Agriculture. Next one is the agriculture. First one is the overgrazing completed. Next one is agriculture. In the year, early years of the human existence on the earth, man was just a hunter hunter gatherer and was quite like other animals. He used to do plantation and agriculture agricultural. In early years of human existence on this earth, man was just a hunter gatherer and was quite like the animal species. Some 10,000 to 12,000 years ago, he took to agriculture by the cultivating plants of his own choice. He used to do practices of this slash and born cultivation or shifting cultivation, which is still prevalent in many tribal areas, as in the northeast hills of India. The types of agricultural practice these days is very different from the traditional one, and their outputs in terms of the yield as well as their impacts on the environment shows lots of the lots of differences. What is the traditional agricultural and its impact? The traditional agricultural usually involves a small plots, simple tools, natural available water, organic fertilizers, and a mix of crops. It is a more near to natural conditions, and usually it results in low productions. It is still practiced by about of the global population. The main impact of these types of agriculture as follows: the deforestation, soil erosion, depletion of the nutrition. The deforestation is the slash and the burn of the trees in forest to clear the land or cultivation, and a frequent shifting result in loss of forest cover. Soil erosion, the clearing of forest cover exposes the soil to wind, rain, and storms, thereby resulting in loss of top fertilized layer of the soil, depletion of the nutrients during the slash and burn the organic matter in the soil gets destroyed and most of the nutrients are taken up by the crops within the a short period. This making the soil nutrient poor, which make the cultivators shift to another area. What are the modern agriculture and its impact? Modern agriculture makes use of hybrid seeds of the selected and the single crop variety. High tech equipments and lots of energy subsidized in the form of fertilizers, pesticides, and irrigation water. The food production has increased tremendously, evidenced by the Green Revolution. However, it also gave rise to several problematic offshoots. The major impact of the modern agriculture are discussed here. The impacts related to high yielding varieties. The uses of the high yielding varieties encourage the monoculture, that is the same genotype genotype is grown over vast areas. In case of an attack by some pathogen, there is total devastation of the crop by the disease due to exactly uniform conditions, which help in rapid spread of diseases. Fertilizer related problems, micronutrients imbalance, nitrate pollution, eutrophications, pesticide related problems. These are the problems. Micronutrients problems is the most of the chemical fertilizers used in modern agriculture have nitrogen, phosphorus, and potassium (NPK), which are essential micronutrients. Formerly, usually farmers usually use the fertilizers indiscriminately to boost up crop growth. Excessive use of the fertilizers cause micronutrient imbalance. For example, excessive fertilizers used in Punjab and Haryana has caused deficiency of the micronutrient zinc in the soils, which is affecting productivity of the soil. Nitrate pollution. The nitrogenous fertilizers applied in the fields often leach deep into the soil and ultimately contaminate the groundwater. The nitrates get concentrated in the water. When their concentration exceeds 25 mg per liter, they become the cause of a serious health hazard called blue baby syndrome or methemoglobinemia. These diseases affect the impact of the maximum extent, causing even death. In Denmark, England, France, Germany, Netherlands, this problem is quite prevalent. In India, also problem of nitrate pollution exists in many areas. Eutrophication, excessive use of nitrate and phosphate fertilizers in the agricultural fields leads to another problem which is not related to the soil but relates to water bodies like lakes. A large proportion of nitrogen and phosphorus used in the crop fields is washed off and along with the runoff water reach the water bodies, causing over the nourishment of the lakes, a process known as a eutrophication. U means more, trophic means nutrition, and more nutrition. Due to the eutrophication, the lakes get invaded by the algal blooms. These algal species grow very fast by rapidly using of the nutrients. They often produce toxins and badly affect the food chain. The algal species quite quickly completed their life cycle and die, thereby adding a lot of dead organic matter. The fish get also killed due to toxins, and there is a lot of dead matter that start getting a decomposed. Oxygen is consumed in the process of the decomposition, and very soon the water gets depleted of dissolved oxygen. This further affects aquatic fauna, and ultimately anaerobic conditions are created where only pathogenic anaerobic bacteria can survive. Thus, due to the excessive use of the fertilizers in the agricultural fields, the lake ecosystem gets degraded. This shows how an unmindful action can have for reaching impact. The pesticide related problems, the thousands of the thousands of types of pesticides are used in agriculture. The first generation pesticides include chemicals like sulfur, arsenic, lead, mercury used to kill pests. DDT, dichlorodipinyl trichloroethene, DDT, insecticidal properties of which were discovered by Paul Muller in 1939 belongs to the second generation pesticides. After 1940, a large number of synthetic pesticides came into use. Although these pesticides have gone a long way in protecting our crops from huge losses occurring due to the pests, and yet they have a number of side effects discussed below, creating resistance in pests and producing a new pest. Some individuals of the pest species usually survive even after pesticides spray. The survivors give rise to highly resistant generations. About 20 species of pests are now known which have become immune to all types of pesticides and are known as a super pests. Death of non-target organisms. Many insecticides are broad-spectrum poisons which not only kill the largest target species but also several non-target species that are useful to us. Biological magnification. Many of the pesticides are being non-biodegradable, keep on accumulating in the food chain, a process called biological magnification. Some human beings occupy a high trophic level in the food chain. They get the pesticides in a biomagnified form, which is very harmful. Waterlogging. Over irrigation of the croplands by farmers for good growth of their crop usually leads to waterlogging. Inadvertently, inadequate drainage causes excess water to accumulate underground and gradually form a continuous column with a water table. Under waterlogging conditions, pore spaces in the soil get fully drenched with water and the soil air gets depleted. The water table rises while the roots of the plants do not get adequate air for the respiration. Mechanical strength of the soil declines, the crops plants get large and the crop yield falls. In Punjab and Haryana, extensive areas have become waterlogged. Our advocate canal water supply or tube well water encourage the farmers to use it over enthusiastically, leading to waterlogging problems. Preventing excessive irrigation, subsurface drainage technology, and bio drainage with trees like eucalyptus are some of the remedial measures to prevent waterlogging. Salinity problem at present, one third of the total cultivable
land area of the world is affected by salts. In India, about 7 million hectares of the land are estimated to be salt affected, which may be saline or sodic. Saline soils are characterized by the accumulation of the soluble salts like chloride, sodium sulfate, calcium chloride, magnesium chloride, etc. In the soil profile, their electrical conductivity is more than 4. Sodic soils have carbonates and bicarbonates of the sodium. The pH usually exceeds 8, 8.0, and exchangeable sodium percentage is more than 15%. The major cause of the salinization of the soil is excessive irrigation. About 20% of the land power plants receive irrigation with canal water or groundwater, which, like rainwater, often contains dissolved salts. Under dry climates, the water evaporates, leaving behind salts in the upper soil profile. The thousands of hectares of land area in Haryana, Punjab are affected by soil salinity and alkalinity. Salinity causes stunted plant growth and lowers crop yields. Most of the crops cannot tolerate high salinity. Remedy: the most of the common method for getting rid of salts is to flush them out by applying more good quality water to such soils. Another method is laying underground network of the perforated drainage pipes for flushing out the salt slowly. This subsurface drainage system has been tried in the experimental stations of CSSRI at Sampla, Haryana. The Central Soil Salinity Research Institute (CSSRI) means Central Soil Salinity Research Institute, located in Karnal, Haryana, has to its achievement the success story of the converting Jarifa Warren village to Jarifa Abad, that is from barren land to barren land productive land to through its research application. Case studies: salinity and waterlogging in Punjab, Haryana, Rajasthan. The first alarming report of the salt-affected wasteland formation in the connection with irrigation practices came from Haryana. Then Punjab. In 1858, it was reported that several villages in Panipat, Rohtak, and Delhi, lying in command area of Western Yamuna Canal, were suffering from destructive saline efflorescence. The Reha Committee in 1886 draw the attention of the government on the same vital points, showing a close relationship between irrigation, drainage, and the spread of Reha and Usar soils. The floods of 1947, 1950, and 1952-56 in Punjab resulted in the aggravated waterlogging with serious drainage problems, introducing of canal irrigation in uncontrolled Haryana resulted in rise in water table, followed by the waterlogging and salinity in the many irrigated areas, using huge economic losses as a result of fall in crop productivity. Rajasthan too has suffered badly in this regard following the biggest irrigation project, Indira Gandhi Canal Project, and the suffering of a big area in western Rajasthan have changed from a condition of the water-starved wasteland to that of a water soaked wastelands. Yeah, next topic is the third unit is the energy resources. We have completed mineral resources, use and their others. Second one is the food resources and then their uses and others. Third one is the energy resources. How important are energy resources? Energy consumption of a nation is usually considered as an index of its development. This is because almost all the developmental activities are directly or indirectly dependent upon energy. We find wide disparities disparities in per capita energy use between the developed and the developing nations. The first form of the energy technology probably was the fire, which produced heat, and the early man used it for cooking and heating purpose. Wind and the hydropower have also been in use for the last 10 10,000 years. The invention of the steam engine replaced the burning of wood by coal and coal was later replaced to a great extent by oil. In 1970s, due to Iranian revolution, Arab oil em- embargo, the prices of oil shot up. This ultimately led to exploration and use of several alternative sources of the energy. Growing energy needs development in different sectors relies largely upon energy, agricultural industry, mining, transportation, lighting, cooling, and heating in buildings all need energy. With the demands of growing population, the world is facing further energy deficit. The fossil fuels like coal, oil, natural gas, which at present are supplying 95% of the commercial energy of the world resources and are not going to last for many more years. Our lifestyle is changing very fast, and from a simple way of life we are shifting to a luxurious lifestyle. If you just look at the number of electrical gadgets in your home, the number of private cars and scooters in your locality, you will realize that the last few years they have multiplied many folds and all of them consume energy. Developed countries like USA, Canada constitute about 5% of the world population but consume one fourth of the global energy resources. An average person, an average person, they consume 300 gigajoules equal to 60 barrels of oil per year. By constant average man in a poor countries like Bhutan, Nepal, or Ethiopia consume less than 1 gigajoules in a year. So a person in a rich country consume almost as much energy in a single day as one person does in a whole year in a poor countries. This clearly shows that our lifestyle and standard of living are closely related to energy needs. The strong correlation between per capita energy use and the gross national productivity in USA, Norway, Switzerland, etc. with high GNP show high energy use, while India, China, etc. have low GNP and low energy use. Bahrain and Qatar are oil-rich states, UAE, and hence their energy consumption and GNP are more, although their development is not that high. Renewable and non-renewable energy resources. What are the major resources? What are the major resources of energy that we use? A source of energy is one that can provide adequate amount of energy in a usable form over a long period of time. These sources can be of two types: non-renewable. Renewable resources which can be generated continuously in nature and are inexhaustible. Example: wood, solar energy, wind energy, tidal energy, hydropower energy, biomass energy, biofuel energy, geothermal energy, and hydrogen. These are the regenerative energies. What are the wood means? Again, we plant the plants, we generate the wood. Solar energy, wind energy, tidal energy, hydropower energy, biomass energy, biofuel energy, geothermal energy, and hydrogen energy. These are the regenerative energy. They are also known as the non-conventional sources of energy, and they can be used again and again in an endless manner. Non-renewable resources which have accumulated in nature over a long span of time and cannot be quickly replenished when exhausted. Example: coal, petroleum, natural gas, nuclear fuels like uranium, thorium. Coal, once we can explore it, we cannot regenerate it. Petroleum also same. Once we can explore it, we cannot regenerate it. Natural gas also same. Nuclear fuel also same. Wood is a renewable. Wood is a renewable resources, as we cannot get new wood by growing a sapling into a tree within 15 to 20 years, but it has taken millions of the years for the formation of the coal from trees and cannot be regenerated in our lifetime. Hence, coal is not renewable. We will now discuss various forms of renewable and non-renewable energy sources. Solar energy. Solar energy. Sun is the ultimate source of the energy, directly or indirectly for all other forms of the energy. The nuclear fission reactions occurring inside the sun release enormous quantities of energy in the form of heat and light. The solar energy received by the near Earth space is approximately 1.4 kilojoules and seconds, known as a solar constant. Traditionally, we have been using solar energy for drying clothes and food grains, preservation of the eatables, and for obtaining salt from seawater. Now we have several techniques for harnessing solar energy. Some important solar energy harvesting devices are discussed here. Number one, solar heat collectors, solar cells. These can be passive or active in nature. Passive solar heat collectors are natural materials like stones bricks, etc., are materials like glass which absorb which absorbs heat during the daytime and then release it slowly at night. Active solar collectors pump a heat absorbing medium, air and water, through a small collector which is normally placed on the top of the solar cells. They are also known as photovoltaic cells or PV cells. Solar cells are made of thin wafers of semiconductors materials like silicon and gallium. When solar radiation fall on them, the potential difference is produced which causes flow of electrons and produces electricity. Silicon can be obtained from silica and sand, which is abundantly available and inexpensive by using gallium arsenide, cadmium sulfide, or boron. Efficiency of the PV cells can be improved. The potential difference The potential difference produced by the single PV cells of a 4 cm square size is about 0.4 to 0.5 volts and produces a current of 60 milliamperes. A group of solar cells joined together in a different pattern form a solar panel which can harness a large amount of solar energy and can produce electricity enough to run street light, irrigation, water pump, etc. Solar cells are widely used in calculators, electronic watches, street lights, traffic signals, water pumps, etc. They are also used in artificial satellites for electricity generation. Solar cells are used for running radio and television also. They are more in use in remote areas where conventional electricity supply in a problem. Solar cookers. Solar cookers make use of solar heat by reflecting the solar radiations using a mirror directly onto a glass sheet which covers the black insulated box within which the raw food is kept. A new design for a solar cook is now available which involves a spherical reflector, concave or parabolic reflectors. Instead of the plain mirror that has more heating effect and hence greater efficiency. The food cooked in solar cookers is more nutritious due to slow heating. However, it has the limitation that it cannot be used at night or on cloudy days. Moreover, the directions of the cooker has to be adjusted according to the direction of the sun rays. Solar water heaters. It consists of an insulated box painted black from inside and having a glass lid to receive and store solar heat. Inside the box, it has black painted copper foil through which cold water is is made to flow in, which get heated and flow out into a storage tank. The hot water from the storage tank heated on rooftop is then supplied through pipes into the buildings like hotels, hospitals. Solar furnaces. Here, thousands of solar plane mirrors are arranged in concave reflectors, all of which collect the solar heat and produce as high a temperature of 3000 centigrades. Solar power plant solar energy is harnessed on a large scale by using concave reflectors which cause boiling of water to produce steam. The steam turbine drives a generator to produce electricity. A solar power plant 50 kW capacity has been installed at Gurgaon, Haryana.
I stopped the class to this time up to we have completed the solar energy. Now next class we have started the wind energy, tidal energy, hydropower energy. These topics covered in next class are geothermal energy. These topic ocean thermal energy. These topics are we discussed biogas, biofuel, hydrofuels. These topics we are covered in coal, petrol, natural gas. These topics covered in next class. Nuclear energy also, soil erosion, land resource. Thank you to everyone to listening my class. Thank you to everyone.